All right, in this video, you're going to see that the objective is the students will be able to use the discriminant to determine the number of solutions. All right, keyword here is discriminant. All right, that's part of the quadratic formula. Okay, and that will help us determine the number of solutions, or what kind of solutions, how many. All right, so that's what we're going to be doing. So the discriminant is the stuff under the radical. So if you remember, the quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. So we're talking about the stuff that's under the radical. In other words, all of this right here, which is what we're talking about. So we're just looking at b squared minus 4ac. So again, everything has to be in standard form for us to use this. Now, when I plug in a, b, and c and simplify it, do I get is it greater than or is it a positive value? Do I get a positive value? If I get a positive value, that means I'm going to have two real solutions. All right. If I plug it in and I simplify it and I actually get 0, in other words, it's equal to 0, that means I get one real solution. Or if I plug it in, b squared minus 4ac, and end up getting a negative value, because a negative is less than 0. If I get a negative answer, that means I have two complex solutions. That means my answers will have a plus the form of a plus bi. In other words, I'll have an I in my answer. All right, but we don't want the actual answers. We want to know, is it two real, one real, or two complex? That's all we want to do. All right, so let's look at our first equation. So we follow the exact same steps. Step 1, it must be equal to 0. All right, it is. So step 2 is we're going to list our A, B's, and C's. So first of all, A is 9. B is 6. And C is 1. So now we're going to apply the quadratic, or the discriminant, in other words, we just want to do b. You want to do b squared minus 4ac. That's the only thing we're doing. So b is 6, so we're going to do 6 squared minus 4 times a. A is 9 times c, which is 1. So 6 squared is 36. And negative 4 times 9 times 1, that's a negative 36. So 36 minus 36 is 0. All right? And since it's 0, as I said before, we got 0, so it'll be one real solution. So I would say 1 real solution. So when you're doing these problems, I want to see this work. Right? I need to see the work to get credit. Okay, let's look at another example. All right, let's find the discriminant. How many and what type of solution does this quadratic have? All right, you notice it's already equal to 0. So A is equal to 9. B is equal to 6. C is equal to negative 4. So now we're going to do b squared minus 4ac. So b is 6, so it'll be 6 squared minus 4 times a. A is 9. C is negative 4. All right. So here, 6 squared is 36. Negative 4 times 9 times negative 4. All right, so let's put that in a calculator. So we have Let me turn it on first. So we got -4. Now, come on, turn on. Now it doesn't work. And -4. There we go, folks. We're in business now. So -4 times 9 times -4. Enter, and I get 144. Positive 144, that is. My word. So I get positive 144. So 36 plus 144 is 7, 8, 180. Now that is positive. It's positive 180. So that means it's greater than 0 because it's positive. So therefore it's 2 real solutions. You must show your work. All right, go ahead and try this one. Hit pause, list your A, B, C, do the discriminant, and then tell me the type of solution. Is it real? And how many? Is it 1, 2, or complex? 1 or 2, or and is it? I can't talk today. Is it real or complex? All right. So first thing we do with this A. So A is 9. B is 6. And C is 5. All right, so B squared minus 4AC. So B is 6 squared. Hello, let me rewind. So it's 6, all right. B squared will be 6 squared minus 4 times A times C. So that's 36. Okay, so -4, 9, and 5. So we're going to do -4 times 9 times 5, -180. So I get -180. So 36 minus 180 is 144. Excuse me, -144. Since it's a negative, that means it's less than 0. So that means I have 2 complex solutions. All right, that is it. If you have any questions, make sure you send me a message, and I'll be glad to get back to you.